Dear Regina Sailing family and friends and all others who have followed me now in celestial navigation. Now we come to the fantastic celestial bodies, the stars. And there are so many of them. So we'll use a couple of them for navigation. Now, twilight is the only problem that we have with stars. Otherwise, they will be very useful and nice to use, because there's one invention, the first point of Aries. Let's dig into it.
The stars. Nothing is as romantic and connected to celestial navigation as the stars. But they look a bit frightening and difficult maybe because there are so many of them, and you think and believe that you must recognize them and all the constellations. Not at all so. It's so much easier. Hadn't it been for the sake that you can only shoot them at twilight, we would use them much more, because they are very practical. The good thing is that they don't have any semi-diameter, they don't have any parallax because they're so far away, and the best thing about them, they are where they belong and don't move around. So they are exactly positions in relationship to each other. It's just the Earth turning, so we see a part of the sky and the whole sky is moving above our heads, one can say. There are millions and millions and millions of stars. 6,000 of them are more or less visible. And you don't even have to go so far. We can go down to 58 stars. 58 have been chosen to be navigatable stars. Not because they are the very brightest, because they are very bright, but they are not the 58 brightest. It's the 58 which make most sense and are most helpful. And which is even more practical. There is the Sight Reduction Table, Volume 1, where they have used, out of these 58 navigatable stars, always 7 stars at a time, at a given time and a given assumed position. So these are the 7 stars which they suggest we should use. And then we can use 2 or 3 of them, and wonderfully we get a couple of position lines which cross each other, so we get the position where we are at that time. That's really practical. So, where are the stars? We have to put them in relationship to a certain point, the reference point to everything in the universe. And it's not where the Big Bang was, that could be one thing, but it's here. It's the origin of the sky. It's a point in the sky which the human beings have defined as a practical point looking up from the Earth. And all the other stars are in relationship to this. It's like the 0 point, the origin of a coordinating system in a mathematical graph. Well, let's start off with giving it a name. We'll call it the first point of Aries. That's a very practical point because people have put it above the equator. When you're on the equator, it's just above you. So it has, in other words, a declination of 0, which makes it very practical.
Let me interrupt my slides right now. Did you get what I just said here? How smart it is? I will demonstrate how smart it is. So, you should never compare apples and oranges, and that's what I'm not doing here, because this is my sun and this is my Earth. And now I will show you Aries. So, I take some tape, a piece of paper, and put it up here on the back. There. And take a pen and make a cross. There, may I introduce Aries. It's in the sky. That is Aries. And here is the sun. I will place it here in the middle. And here is the Earth. Put it that way. This is my North Pole. So I need a nice equator. I need to sacrifice this nice apple because I don't want to eat my pen. I can eat my hat, but I don't eat my pen. So this is sort of equator. And then I have myself, or you maybe. So I'm standing on the equator right now. So now let's see how the Earth turns around the sun in summer and in winter and spring and autumn and what Aries is doing at the same time. Here we can see in the summer that the northern hemisphere is tilting towards the sun. That's why we have it nice and warm. So the sun is now shining on the northern hemisphere. So the sun has a northern declination. Yet Aries, which is pointing this way, is still over the equator. So even that the sun has a declination on the northern hemisphere, Aries does not. And then when we move over to autumn here, and the Earth is turning, the Aries is still turning over the equator, has still no declination, and the sun has not a declination either, because sun and Earth and Aries are all in one line on the 21st of September. This is because we are going towards autumn. And even if we go over here to winter, again the sun has a southern declination, but Aries has no declination. So this is a really, really smart position in the universe where human beings have just made a cross somewhere in the sky where there is no declination. So that is the first point of Aries.
Here it is. So if we are looking from the equator, that's the gamma point there on the Earth, looking up in the sky, you would see the first point of Aries. And it is always above the celestial equator, as you can see there. Never has a declination. It's the yellow line. So the Earth is turning, point of Aries is always where it is, and it's always above the equator. Now, so it is not with the sun. That's the red circle. The sun is not always above the equator. It's actually only twice above the equator, 21st of March and 21st of September, because it goes along this red line called the ecliptic line around the Earth. So it is very much to the north. It has a declination of about 23 degrees when you are on the 21st of June. And on the other side of the Earth, on the 21st of December, it has a declination of about the same 23 degrees as far south as you can get. And all the other stars are put in relationship to that. So all stars have, in relationship to the first point of Aries, a so-called side hour angle. So the total Greenwich hour angle of a star is the Greenwich hour angle of first point of Aries plus the side hour angle. And the same applies to the declination. So the declination of a star is the declination of the first point of Aries, which is 0, plus its own declination. So if you only know where the first point of Aries is, and you know the side hour angle and the declination of the star, you can calculate its position in the sky. Now there are two schools of doing this. The old school, that is to find the star in the sky. So that means you have to recognize it. And when you've recognized the star, you can then find this, and you do like I said now, you add the side hour angle and the declination to Aries, and then you use the normal planet proforma, because the planet proforma, like you used before, is just working for the stars just as well. Now we have a little problem there. First of all, the site reduction tables only work with a declination less than 30 degrees. And that is the big difference between the air site reduction table, which we normally use, and a nautical site reduction table, which works with any declination. But that would bring so many heavy books on board, so it's better to use the air site reduction table, despite the fact that it works for declination only under 30 degrees. So you couldn't use it for all the stars. And the second biggest disadvantage is that you have to identify the star in the sky. And that is not so easy. You can have star finders, I'll come back to that, and we can play around with that on our courses, either the theory courses or the practical courses on board Regina Alaska. That's a lot of fun to identify stars. It's not so difficult. but it's still difficult if you want to do it with your naked eye, and then it's a lot of calculational work with the site reduction table and the planet performer. Now, this is how they did in the olden days. Now, the new school, that's so much more smart. That is what I am teaching and what I am doing and what I've hinted at so many times. What you do is you prepare for twilight. That is what we've done so far. Then you choose some relevant stars taken from the volume 1 of the site reduction tables. And here, in these site reduction tables, they have pre-calculated the height and the rough azimuth, Zn, of that star in question. And as I've mentioned a couple of times, what you do is you set the sextant to that angle, you look into the direction of the azimuth, and that's the star. And never mind its name, there are so many nice names of stars. If you want to do the old school, or if you are not quite sure which star it is, or if you want to know where the planet is in the sky, then we have these star finders, 2102-D it's called, from Wemsenplaat. They are much, much easier to use than they look here on the screen. Now, with disregard from all this here, I just wanted to mention you that we can play around with that star finder. It's really, really funny. So we'll go back to now doing the calculations of the areas to see which stars we want to choose. So we take our template which I have prepared. So you remember we did this with the planets, they are shaded here. So now we do the same with areas. So we take the approximate declination of areas, well that's 0. Then you look at the approximate Greenwich hour angle at full hour for Aries. We read off that from the daily pages, the Greenwich hour angle of Aries. Don't look it up for the sun or some planets. Aries has its own column of Greenwich hour angle. You take the increments, that's very easy because it's nice 15 degrees per hour. And then you take the Greenwich hour angle and look what is the Greenwich hour angle now total at twilight and hour position. You choose the longitude by yourself so that the local hour angle becomes a full degree. Nothing new. Next, you look into the site reduction table volume 1. You look at the corresponding page for your latitude and your local hour angle, and there are 7 stars. So it looks like that. You find it in volume 1. So you have pre-calculated a local hour angle and you know your latitude. So let's say your latitude is 50 degrees, and then you have pre-calculated the local hour angle for twilight. So let's assume that twilight is at 2120, and at 2120 you have a local hour angle of 281 degrees. So we write down 2120 here at 281 degrees. Now the good thing is every degree of the local hour angle corresponds to 4 minutes, because the Aries and the Sun, they all have a nice increment of 15 degrees per hour, or 4 minutes for a degree. So next to the 280, you can write 2116, which is 4 minutes before. And next to 279, you can write 2112. Later, 282 local hour angle, you will find at twilight plus 4 minutes, which is 2124. And then the next one, 2130. So then you have the twilight hours, 2112 to 2130. So you can exactly read off what happens at these times. So let's assume let's look at what happens at 2116. Then you have a local hour angle of 280. And there you should see the star Altair. You don't have to remember what its name is, but it's called Altair. It has capital letters, which means it is very visible, very bright, and it has a diamond, which means it's perfect for getting a nice fix. So at 2116, in other words, local hour angle 280, you will see Altair at a height of 46 degrees and 20 minutes on the sextant, and the azimuth, the direction, to that star Altair is 155. So all you have to do at 2116 is to set your sextant at 46 degrees in 20 minutes, use your hand-bearing compass and look at 155 degrees towards the horizon, and there it should be, somewhere in the sextant. Then at 2120, you have a local hour angle of 281. You should see Arcturus, which is also a very bright star, which has a diamond, on 29 degrees and 9 minutes on the sextant in a direction of 266 degrees as an azimuth. And at 2124, which means the local hour angle at 282, you should see the third star here in the middle, which I can't even pronounce, at 49 degrees at 37 minutes on the sextant in the direction of 209. So when you found those, you look through, you have preset the sextant, there it is, good. Then you take the exact height and note the exact time, and then all you do then is that you do the sight reduction for the stars, which is so much simpler than with the sun and the planets. So let's go and do some exercises.